Well, welcome to a question a day, day 8. Chemical plant food loses its effectiveness at a rate proportional to the amount present in the soil. The amount of food effective after T days satisfies the differential equation that dm dt equals Km. Find the general solution for M in terms of T when the initial amount of food is M naught. All right. So let's do part A. Let's find this general solution. We know that dm dt equals Km is given to us. So let's separate the variables. Dm on m equals K dt. And let's crack out an integral of both sides. Now, this would be the natural log of the absolute value of m equals kt plus c. Now, the amount of m is the amount of the fertiliser, so it's always positive, so I don't have to worry about the absolute values. So I'm just going to let it be ln m is kt plus c. Okay, now what I'm going to do next is just say that says raise both sides like e to the power of the left side and e to the power of the right side, which means I'll get m is equal to e to the kt plus c. Then that's m equals e to the kt times e to the c, and that means that m equals a e to the kt, where this a is equal to e to the c. Right? So I get down to there, and then they've said m naught is the amount that's present at the start. So when t equals 0, m equals m naught. So m naught equals a e to the k times 0. So e to the 0 is 1. So a is m naught, which means that I can write down that m equals m naught e to the kt. Now you would hopefully have just been able to jump to that, having done a few of these similar questions. All right, but that's the general solution that they're wanting there. Find the value of k if after 30 days only half the initial amount of plant food is effective. Okay, so B, when T equals 30, just check that the time is in days in the question. T days, yes it is. So when T equals 30, now I've gone and forgotten what the question was. Find the value of K if only half the initial amount of plant food's there. Okay, so when T equals 30, M equals half of the original amount. So half of M naught equals M naught E to the KT. Divide by M naught, 0.5 equals E to the KT. And T is 30, isn't it? So let's pop that in there, 30. So we'll take the natural log of both sides. So we get the natural log of 0.5 equals 30k. So k equals the natural log of 0.5 on 30. Now the natural log of a fraction, like anything less than 1, is negative. Sometimes that rings alarm bells, but it's fine because we actually have a quantity that's diminishing away, so I'm not particularly concerned about that. And I just put that into the calculator, and the natural log of 0.5 and then divided by 30 is negative 0.02310490602. So oftentimes we go to 4 decimal places, So 1, 2, 3, 4. I might leave it at that. They haven't said. All right, what's the next thing we need to do? Well, what percentage of the original amount of plant food is effective after 35 days? Okay, so when T equals 35, M equals M naught, E to the minus, and this is our K now, T. So M compared with M naught is E to the negative 0.0231 times 35 in this case. So the fractional relationship, you know, the comparison between them is M on M naught, the amount we've got compared with the original amount, and that's equal to E to the negative 0.0231 times 35. So let's pop that in the calculator, negative 0.0231, and let's multiply that by, go back again, times 35, make sure it's all powered up to that. And we get that M, sorry, just need a bit more room, M on M naught is equal to 0.44552585, right? Now that's as a fraction, so we know to turn any fraction to a percentage, you multiply by 100, so it's about 44.55%, something like that, right? About 45%. If I had to do it to, like, again, you'd want to look at the question in an HSC exam and be more as specific and answer the question as you've been asked. But there, that gets you to the method to get the answer. And then what else we asked? The plant food has to be renewed when its effectiveness falls below 25%. Is the manufacturer of the plant food justified in calling its product 60-day superfood? So what they're trying to say is, does it stay above 25% effective all the way up to 60 days? If it does, then it's supposedly okay, but it's got to be renewed if it falls below 25%. So it could even equal 25% at the 60-day mark. So let's just, it's sort of like we're reversing that question we just did. You know, we're wanting to say that with M equals M naught, E to the, what is it, minus 0.0231 T, we're wanting to say this fraction here, M on M naught, we want that to be equivalent to 25%, right? 25%, we want that. We want T to end up being 60 days or less than 60 days. So that's one way to do this. So I'll figure out what T is in this case. 0.25 equals 0.231T. Take the log of both sides. So T is natural log of 0.25 on negative 0.0231. Natural log of 0.25 on negative 0.0231. And I get 60.0127. So slightly after 60 days, it's down at 25%. So it's yes, manufacturer is justified. In making the statement. Because there is still 25%, more than 25% in the soil after 60 days. It's close, 60.01, but they make it in there. So yes,